algebra students, Mr. Lawrence here with another flipped lesson, and we're just going to look at some special types of factoring which make our job very, very easy. All the other ones has had a little bit of work in them, and these patterns are called the difference of perfect squares, and you got to understand what word difference means. When you see the word difference in math, you need to be thinking subtract. And I guarantee you, many of you will not think subtract, and therefore you will have a hard time with this one. But if you think subtract, you'll catch whenever Mr. Lawrence is trying to be tricky. All right, and then the other one is I can factor perfect square trinomials. And I'm going to explain what those are. Obviously, they're trinomials that have perfect squares in them, but we are going to see what happens. First, we're going to look at problems 1 through 3 here. And I'm going to tell you 1 through 3 fit the pattern called difference of perfect squares. Well, first of all, it's difference, right? Which means what, fish? Subtract. And notice that 1, 2, and 3 all have a subtraction sign in them. Only one subtraction sign. You see two negatives in, like for example, if the 3 was negative, this probably couldn't be the difference of perfect squares. In fact, I know it couldn't, but I'm just trying to be careful in case there's some unusual circumstance. Okay, so the difference of perfect squares, we need to check. Is x squared a perfect square? It sure is. What's the square root? Well, the square root is x, right? Okay, is 25 a perfect square? It is. What's the square root? Well, it's 5, positive square root. Here's how this factors. Now watch, this is really tough. X plus 5 times the quantity of x minus 5. And you're done. If you're not sure, FOIL it. Watch, you'll get x squared minus 25. Okay, this only works when it's the difference of perfect squares. It's only that simple. All right, so we already know 2 is subtraction. X squared is a perfect square. Square root is x. 144 is a perfect square. 12 is the square root. Here's how it factors. Quantity of x plus 12 times quantity of x minus 12. And there you go. You are done. Okay, now, this one has subtraction, but 3 is not a perfect square. Neither is 27. What's the first type of factoring you should always try? What's that? GCF. Yes, I'll pull the GCF out and get 3 times the quantity of x squared minus 9. Inside the quantity, do I have a subtraction sign? I sure do. Do I have a perfect square? X is a perfect square. Do I have 9 a perfect square? It sure is. This one factors just like this. 3 from here times the quantity of x plus 3 times the quantity of x minus 3. Pretty simple stuff. That's the difference of perfect squares. Now, the next type we're going to learn are called perfect square trinomials. Perfect square trinomials. And first of all, your first term and your last term must be perfect squares. Okay? So I'm going to put x here, 5 there. They are definitely perfect squares. And then I'm going to multiply them and double the answer. 5x, and when I double it, I get 10x, don't I? Notice how it matches? If that's the case, it factors like this. X, X, and since they're both going to be 5, and then I look here, a plus in the back is the Wendy's double stack. I use this sign twice. There's a single stack and there's the double stack. And I am done. All right, let's check this one. 9x squared a perfect square? It sure is. 3x is the square root. 15 a perfect square? Absolutely. 4. Multiply them to get 12x. Double that and you get 24x, don't you? And it matches. So I take 3x and 4. I take 3x and 4. Plus in the back. Wendy's double stack. They're both negative. And there we are. All right, let's try this one. 121x squared. is a perfect square. The square root is 11x. 144y squared, or should I say Trevor y squared. 144 is a perfect square, so it would be what, 12y would be the square root. I'm going to multiply these two together to get 23xy. Going to double 23, what am I going to get? 46xy. It matches. This factors 11x, 12y, 11x, 12y, plus in the back, the Wendy's double stack. And there you go. Pretty easy stuff. Now, I'm going to try to trick you. Okay? I'm going to try to trick you. Give you two problems here. X squared plus 9. And the other one is going to be x squared minus 6x minus 9. Okay? Go ahead and see if you can factor these two on your own using those techniques. All right? Here comes my solution. This one is prime. Cannot be factored. Not no solution because we're not solving for x. It's prime. But Mr. Lawrence, it's the difference of perfect squares. It is not. Do you see a subtraction sign? No, 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 no. It's the sum of perfect squares. But we don't have a pattern that says sum of perfect squares. You cannot factor this. If you factored it like this, and you FOILed, what would happen when you got your lasts? You'd get a negative 9. We have a positive 9. What would happen if you did them both positive? Well, then your outers and inners wouldn't cancel. You'd have a 3x and a 3x. You'd have a plus 6x in there. There is no plus 6x. If you did them both negative, you'd have a minus 6x. There is no minus 6x. All right. Now this one here. Is x squared a perfect square? Yes, it is. Is this one a perfect square? No, it is not. It's a negative 9. Do you know number times itself that equals negative 9? I don't. Okay, now it might be able to be factored, but it's not a perfect square trinomial. Let's test it here. Let's do the trinomial method. Let's put 9 over here, and 1, 9, and then 3 and 3. Okay, now is there a way to subtract any of these factors and get negative 6 for an answer? No, there's not, because if I make both of these negative, isn't that really addition? A negative 3 and another negative 3? That's negative 6, but that's addition. Okay, if I tried it as x minus 3 times x minus 3, which some of you are probably thinking, and I do my lasts, I would get plus 9, not the negative 9. So this one is also prime. I did not know that when I started. All right, that's your video. Make sure you take some notes on it. Come in ready to get some practice tomorrow. Mr. Lord signing off. Good night, everybody.